everyone. I hope you can hear me loud and clear. I will lower down my voice a bit because I have a bit of a problem with my voice, but yeah, let's see how it goes. So welcome to my talk, Squash the Flakes at stackconf. I'm happy to be here. First time here, happy to be again in Berlin. So the agenda of my talk will be first the obvious self-presentation that we do. Then second, I will briefly explain what a flake to me means or to us means. Then I will explain what the impact of flakes is. Then I will explain what flake process we have established in order to try to cut down on the losses that we get from that. Then I will present a couple of the tools that we're using actually in supporting the process. Yeah, and then an outlook to the future and hopefully a good QA session where I want to learn whether you are dealing with that problem also and how you're dealing with it. That's an interesting thing because we are an open source project and we don't have that many external input to how other people or other projects are actually dealing with flakes. This is kind of because this is like a topic that is somehow shoved a bit under the carpet by people like management who don't want to admit that they have flaky tests. They just say, just fix it and then it's fine. But obviously that doesn't work as easy as they say that. Like I said, I'm a software engineer at a Red Hat OpenShift virtualization team, which is the downstream of the KubeVirt project. I'm responsible for looking at KubeVirt CI and keeping it healthy so that our contributors have a pleasant experience when contributing to our open source project. And other topics that I maintain is, for example, like automation in general. So I do most of the things that are somehow related in automating and building things inside our KubeVirt CI. Let's quickly talk about flakes. Can any one of you can explain what a flake is? So first of all, I should probably explain. We are talking about automated testing here, and I figure that most of you are aware of how that works, right? It is obviously connected to testing, so let me put the question around. Who of you has heard about the term flake? Half of these, okay. Can one of you give me like 1 or 2 sentence explanation of what a flake is? Just simply.
The test that sometimes work and sometimes do not, without any clue and without any predictable behavior.
Good point, exactly that. So, to us, a flake is a test that without any code change will either fail or pass in successive runs. So, yeah, so the code base is the point, right? So you have like the production code base and then you have the test code base that accompanies the code base. So this is our scope of what we are looking at today. Because a test can also fail for other reasons, for external dependencies, for example, that are beyond our control. That is not what we're looking at here. So obviously this is also like flaky behavior, but this is not a problem in the tests themselves. This is mostly a problem of the dependency that we're talking to. So, is anyone familiar with Prow? Okay, no one. So Prow is a CI tool that comes from the Kubernetes ecosystem. What you see here in the upper part is this is the web UI of the Prow that Prow shows when you are looking at a pull request history. A pull request is obviously known, all right. Okay, and you know, on that note, you know what a periodic job and a pre-submit job is? Just so to be clear, if I have to understand, you know that. So since not everyone knows that, so pre-submit jobs are triggered whenever there is a push to any pull request or actually to any branch. So then, no, to any branch not to any pull request. Let me put it like that. The others are post-submit. So what you see here in the upper graphic is that you have a couple of runs. On the left side, you see the different test lanes that we have. Then on the right side, you see a green. I hope that is green. It looks, well, it should be greenish somehow. These are the successful test runs that you see. And on the right, you see like 2 failed test runs. What you can see here is actually that in the first run, on the most upper lane, there was a failure in the test run. And on the second and on the third, there was no failure. So it could be that there is a flake hidden. So what do you think? Is this topic about flakes, do you think that is important? Do you deem that important somehow? If you do, please raise your hand. I just want to know how many people find it important or not. Okay. Okay, more than half at least. I hope I can convince the remaining people here until the end of the talk. Let's see. Another question. The folks that are dealing with flakes, does it occur regularly? No, it doesn't. Right. Nice. It does. Okay. Anyone else? Regularly? So, how often do you have to deal with it? Like monthly, weekly, daily? Oh, okay. That's really bad. I've been there too. So there is a very interesting survey by the, I can't remember the universities that actually did that, but this is a meta-survey about flaky tests. And they, I don't know how many other papers they looked at. It must have been around like 70 or 80. I can highly recommend it. They distilled the information of all those papers into this one paper. And this is like my holy grail of trying to fight flaky tests. I'm always consulting that thing. So what I can cite from that is that test flakiness to the most people that were actually asked was a frequently encountered problem. And 20% of the respondents claimed that they had an experience of monthly flakes, then 24 weekly and 15 even daily. So I think it matters. But also 91% of the developers who claim to deal with flaky tests said they would think that this is a moderate problem, and 23 even thought that there was a serious problem. I mean, this is not like completely like a resembling of the survey here, but I hope we get there. Let's see. So again, flakes are caused either by production code or by test code. So when we look at another data from this survey, 97% of those flakes were false alarms. So false alarms in that sense means that the code under test is actually not broken. It does what it does and what it should do, but the test somehow has a problem with it. And then more than 50% of the flakes could not be reproduced in isolation. So you have a test and you try to reproduce it, and then you think, okay, seems to be all is well with this test. So this is fine, right? No, it's not. Because we are talking about CI. Our main source of truth is the CI system. And if there is something wrong in CI, it might be spawning serious problems. Because you need a reliable signal of stability inside CI, otherwise you don't know how you're doing. And any failed test run should signal that the product that you are trying to deliver at some point is actually unstable. So if you are having flaky tests inside that, you can't rely on that signal. So actually there is time wasted at that point. So the time wasted is on several different topics. So first of all, actually we want to care about like the feedback cycle for developers, right? So we want to have a short feedback cycle that the developer actually knows whether all is well with the things that they do on pull requests. then there might be if you are normally like gating your merges with pull request tests, as we do, for example, all the required lanes are green, and then the pull request gets merged eventually, if it's like LGTM'd and approved. But if there are flakes inside there, this takes longer. And then, at least in our case, people start to re-trigger the test runs, which is wasting resources, because normally you're just testing everything again, just for one test or for a couple of tests probably. And like, I mean, just to imagine what we're talking about, we have an E2E test suite that has around 1,500 E2E tests. Each E2E test run for us is spawning a complete Kubernetes cluster. Then our KubeVirt is installed inside there, and then the tests are being run. Could you imagine how many resources one test run would somehow take? Just a guess. Like, the test is run inside a pod. Just guess, how many gigabytes would the pod take? What do you think? Tens, hundreds, thousands? I just cut it short. It's 29 gigabytes per test run. That is like, we have 14 cluster nodes, but still, we are not Google. We don't have unlimited resources, right? And whenever there is a test run trigger, these 29 gigabytes are unavailable for other test runs. But the worst of all is that acceleration effects when merging are also like reversed. So Prow has a great feature about testing multiple PRs inside one run, which is called batch testing. I don't know if you know that, but that's a feature where you can like, we've had runs where we had like 10 pull requests inside one run and it got merged. But obviously we have that very seldom because we have flaky tests. Because what's happening then, the test run is completely thrown away and it is divided into two parts, and those two parts are run again. And if you then have flakes, then the same is happening again. Like it's divided until the single PR is tested again, which is like a lot of resource waste. But they don't only cause wasted time, they also cause trust issues. Because people start losing the trust in the automated testing. If they don't trust the test because they are not reliable, right? And obviously, if someone doesn't tell you always the truth, you don't trust them anymore. And that's exactly the same what is happening with our tests. So they start to ignore the test results and just walk away. So I'm just going back to that one. So that's again, I just wanted to say that the testing can be re-triggered, and they are just going away. We are having like a retest bot inside our system that is actually re-triggering the tests whenever there is like the required labels on the pull request so that it deems fit for merging. It is retesting it. This alone somehow sounds like an anti-pattern, and it actually is, but it is established. It was there before I came into the company, so I could not just reverse it. But the thing is, it actually obviously helps in that situation that you, at some point, eventually get the PR merged. But at current, we are trying to cut down as far as possible. And I'm trying to show you how right now. So what we are doing to minimize the impact is actually we take the test out. We quarantine it. This is a term by Martin Fowler. I've included a link inside my PDF slides. I will show you, at the end, I will show you a QR code so that you can download the slides. The quarantining means that you exclude the test from the set of stable tests and put it in another set, which is also run so that you don't lose the information, but so that you don't ridicule the merges. Because if you can't rely on that test, it doesn't make any sense to run it in the pull request. But you want this only for the time the test needs to be stabilized. After that, you want to directly put it back into the set of tests that you're running. So like as early as possible, but only as long as necessary. So what we do, we have regular meetings. Nice meetings, but yeah. There we look at the flake data, and then we look at the detailed flakes. We have priorities, which I will come later to. Then we decide what we are going to do with those. Either we fix them, or the devs fix them, or we quarantine them. Depends on the situation. I will show you later how that goes. Then we hand the action items to the devs, and then at some point we bring the flaky tests. When they are fixed, we bring them back in. So again, this also is a pull request history for a pull request that has a couple of failed runs. And this at the end, by the way, one detail I forgot to mention last time, this small number on the upper left corner of the green area is a Git commit, actually. So that you can exactly see all these builds have been on the same Git commit. So no changes. So again, those test runs might contain flakes. They could also fail for external reasons because we are talking about ET tests here. So this is the base data that we're looking at. So to have this process, we need an easy process of moving the test from the set of stable tests into the set of quarantine tests. We also need a report over possible flaky tests. And at the latest, we need enough runtime data so that developers can look at those tests and see whether what is the problem there and what they need to do to fix, so that they can give an estimate on how long it will take, so that we can decide whether we are going to quarantine it or not. If the fix goes fast enough, we are just waiting for them and they are going to fix it. So let's talk about tools. I have 4 categories of tools. The first one is the essential part, which is the quarantining. This is pretty easy done. We are just working with labels at the test names. So I'm not sure if you're a bit familiar with Ginkgo. This is a testing library for Go, which solves the the dependency tree of tests pretty good. I could recommend that to you too, by the way. So what you can see here, for example, in the upper part is that there is just a quarantine label on the shell script that runs the test. And then in the lower part, you see the test declaration, and it has this quarantine label, which will make the test not run during the pre-submit runs. Again, the periodics, which we execute 2 times a day, so we execute all tests again on the main branch 2 times a day to see how stable we are overall, and these will be also run there, but not when we are looking at merges. Also, of course, we need some overview of which tests have been quarantined. Forgive me the basic layout. I'm not a web UI guy, obviously. But it does what we need. It gives us like direct links into the code base where we can just directly look where the test is located that actually is quarantined. So that we have an overview. By the way, on the left side, you see also how long it's been quarantined. That's old. That screenshot is very old. So normally it should be like, yeah, we've had times where we had like 2 or 3 months of quarantining until the test got stable. But most of these tests are looking at resolution times of around 1 or 2 weeks or something like that. The next one is obviously the metrics. We need metrics so that we can decide which tests are most flaky. The main tool that we are currently using is something that we have developed ourselves. There you see, we have generated some kind of heat map where we can look at which days were the worst and which test lanes were the worst. So the more red that box is, the worse the situation is. this is the overall view, and then we have like a view that shows us per test. Yeah, I mean this doesn't say much. This is actually the test name. So you would see in reverse order the test with the most problems at the top, so that you could look at this and then go down through the list. Because in those meetings, obviously, we always have only like limited time, and we are trying to maximize the output of that one. Then there is a detail view, which shows us on which test failed on which lane, how often. We are therefore looking at only at the data of the merge PRs at that day, because again, whenever a PR has been merged, all the tests have been green at the end. So there might be flaky test chance inside there, so that you can. I don't know if we have. So if you click on these, you would normally see like a small pop-up that you would then be able to navigate directly to the test data, so that you can directly look at the log file. Overall tools like show us the CI health, shows us how we're doing actually. What we're monitoring currently is the merge queue length. So how many pull requests are currently ready for merge. So the average time to merge, the retest to merge, so that's also an important metric because we want to know how we're doing. Our optimal goal would be that there would always be like 0, so no retest. That would be the greatest thing that we would achieve. At the moment, I think we're below a 1 retest on average on every merge PR, which is much better than in earlier days. When we started that process, we were at around 5 on average. Yeah, analysis tools for looking at how hard the impact of a flaky test is. This is like, does anyone, I figure that no one does know OpenShift CI search probably. So we have a known instance of that one, which actually is like a rip grab tool for querying lots of log files actually. It does only just that. It just, you can for example like search for a term inside there, and then look at how the impact is. So what you can see here is this is a test ID, which we sometimes have in test, but you can also look at normal text queries. And what it shows you, you see it on the upper, the impact here. This is most of the time what we look at, because we want to know how high the impact is. So if we are looking at a 5% impact over the last 14 days, for example, this is like the upper border where we are going to quarantine the test. If it's like 25% in the last 2 days, that's also valid for quarantine. So these are our rules, and they worked until now pretty well. Yeah, I'm going to skip test grid, which is just another tool to browse all the test lanes that we have. I would recommend it if you're looking at or working inside the Kubernetes ecosystem and running Prow, but since no one does that, I don't think that this is really necessary or really interesting to you. In recent days, we did. Let me say it differently. I need to take a bit of water. Sorry for the break. So, all that you saw before was actually when the test code was already merged. What we actually want to do, we want to catch it before it gets merged. And that's what I'm trying to show you now. So we have a pull request, pre-submit, that checks the tests and runs the tests that have been changed 5 times in a row, also in random order, to catch the main things that can go wrong during testing. Because one highly highly available reason for test problems or for test flakiness is test dependencies, order dependency. And that's why we run them in randomized order. Also, the cited sorry. The cited paper says that 80% of all the flaky tests are seen inside the first 5 runs. I mean, there might be also tests that only fail every 10,000 runs, but if you get at least 80% of them in that makes really sense. And we have gotten feedback that this has been very effective for catching flakes. Like, very easy, right? Just a simple shell script that repeatedly runs the things, and that catches things before they enter the code base. What we also did, we wanted to not have excessive retesting going on. So the main idea behind that was that if you are not finding any change on a pull request and you are going to retest it, in general, it normally doesn't make any sense. Because there is a problem, if you have a couple of failed runs on that already, it will never go stable, at least to our, like if you have 5 successive runs on the same commit and it still fails, then it doesn't make any sense to go on. That's actually our reasoning behind that. And that's why we actually stopped the retesting on the pull request after 5 retests and no updates on the pull request. So a tool that we developed for ourselves to help people support whenever they run into that retest trap, which I mentioned earlier. So again, the situation we want to look at is that people commit, push, and go home and wait for the retesting to happen. And sometimes this might happen over the night, and then you might, or over the weekend, and then you might have like 15, 20 retests over the whole weekend, but still no chance for the situation to improve. So that's why we look at this and try to ping the authors of the retest of the pull request and try to help them. And also we announce that dashboard to give it to them so that they can look for themselves whether their PRs are inside there or whether they need to take action themselves. So to recap a bit, so what we do is we have regular intervals where we meet and look at the data, follow up with previous action items that we had before, look at the data, derive action items, hand the action items over to the dev teams, and revisit or dequarantine stable tests. I spoiled that already a bit. What we found, what the main sources of flakiness is in general, yeah, the number one most of the time is test order dependencies. So like you have a set of tests and you have a setup, a common setup on the first, and you are reusing, for example, like a shared resource or something, and some test relies on the outcome of another test, and that is a test dependency. Also, concurrency is a real problem at our test suites. So, like data races, for example, that we have also not only on E2E tests, but also on unit tests. We've had lots of time situations where when you start like running those in parallel, for example, or in randomized, or with how's that option called again? Data race? Is it like, or is it race? I think, right? Go-race, yeah, exactly. If you run it like that, then you might notice that there is like a data races occurring, which also leads to test instabilities. Yeah, and one other thing that I often mention is your test on your system might behave like you saw, but on the CI environment it might behave different. So for example, if you have a very fast system, but CI might not be as fast, and then you have your like timeout that you give to the test somehow, that might not be sufficient for the CI system. So you also need to look at to look at where you're executing your data and or your tests, and choose all those values accordingly. So our key takeaways from the recent years was that in general, normally if you are running a CI system, you should definitely identify all the outside dependencies that you have, because they can all break. I mean, we as KubeVirt obviously rely on lots of outside dependencies. For example, Quay is just one thing, and I'm not sure, or even a GitHub outage is a problem, because Prow might then even miss like the events that you should normally get. You can't cover against everything, obviously, because GitHub is like the central source. But if you can, you should stabilize the testing environment as good as you can. What we did, for example, like to cover against like Quay outages, we have a local image mirror that helps us a lot if Quay goes down. In earlier days, it was even a bigger problem when Docker started to like do those rate limit stuff. I figure you guys probably remember. That hurt us pretty much, or pretty bad, I would say. Yeah, and a last thing that I could recommend also is that if you have a testing environment that you are producing on your own, you should use versioning on that one so that you can roll it back. So if a version that somehow has an instability, so that you have a one-stop mechanism to roll back to the previous stable version. That is, just to give you an example, we have, like I told you, that we are running inside Kubernetes clusters, and we have a virtualized Kubernetes cluster that is running inside a pod. So you have a virtual machine inside a pod, and that virtual machine is the node. And we have like a couple of pods who are running, and we are steadily trying to improve things and trying to make other things somehow possible. For example, like using kernel parameters for virtual machines. And if there is something that is breaking, we just have this one switch that we can revert, and then we have the old stable situation back. Yeah, the future. Yeah, lots of things to do. Obviously, we want to collect more data. We want to run the majority of the tests more frequently. And also, like in a similar approach that we do with the pre-check check test for Flakes lane, like running them in random order and running them 5 times so that we catch the majority of flakes. Yeah, steadily improving is obviously one other goal that we have. We are starting to look at other methods to detect flaky tests, for example, like static code analysis, but yeah, we have not gotten to that. We are a small team. In the long term, our optimal goal would be that we would like to create quarantine PRs for flaky tests automatically. But yeah, that's far into the future, I think. So that's all from me. So I would be open to questions. Yeah, go ahead, please.
So thank you very much. That was Daniel Hiller. Applause, applause. So are there any questions from the audience? Yeah, okay, you can speak in there.
Hey Daniel, thank you for your great talk, first of all. Okay, let me set up a little bit of context for my question, because I'm in the dev team, I'm working in the dev team, and we are used to work with a separate DevOps team that is in charge of CI/CD, deployment, all of that stuff. And the most frequent situation that we are facing right now is flaky tests just in the CI/CD pipeline, and locally we are not able to repro them, because everything works as expected. We emulate everything with Docker locally, and we have, most of the time, we have no idea of how to handle it in the CI/CD process. So how do you recommend to deal with them? Thank you.
I mean, that's pretty general question. So I don't know as much about what you're actually testing, but you were mentioning in your talk that you also like have database dependencies and such things. In general,
blob, store object, all of that stuff. So if there is any practice that we can use to, I don't know, to make more reliable the CI/CD process, because we are not able to repro locally, so we have no clue on how to fix them. Maybe something related to network, I can guess.
I mean, you can just run the tests 100 times locally. So at some point it might eventually show. Also, you might expect, like I said, sometimes this is like a test dependency, which is not only visible when you run a single test, but only when you run a set of tests. So I would suggest probably to do exactly that. So to expand the scope until you find the instability somehow, and always like starting to run always in random order, always in several runs. And if you are, I mean, integration tests are another beast. Like they are taking much longer normally. But if you have the time for that, it's worth it. You should actually definitely concentrate on fixing those, because, like I said, this is wasted time for everyone that is working on that problem. And this is time well spent. So investigate, run them in random order, really random order, not with a seed or something, really random order. And then try to find the test dependencies that you have normally. And that should eventually resolve your situation. I hope that this works for you. I'm keeping my fingers crossed.
Okay, thank you very much. Yeah, I think so. We have no more time for more questions because the next talk is in a few minutes.
Oh, sorry, did I?
Yeah, thank you very much. And yeah, let's have a short break.
1 second, please. I just would want to say one more thing. If you could take a screenshot of that one somehow and come back to me with feedback that you have, how you are doing this, how you are dealing with that flaky stuff that you have, I would be really interested in hearing from you. That's all. Thanks.